Is my screen visible? Hello? Is my screen visible?
Yes, ma'am.
Okay.
Yes, ma'am.
Ye-
So can we start?
Okay, ma'am.
Okay. So welcome to NPTEL PMRF tutorials on Introductory Organic Chemistry to August 2023. Today we will be discussing week 1 assignments of previous year. So the course instructors for Introductory Organic Chemistry 2 are Professor Harina Chakrapani and Professor Neeraja Deshaputre. Myself Anisha Suresh, PMRF TF for this course from IIT Bombay. So today's lecture is divided into two sessions. First of all, we will be discussing the summary of the week, summary of the concepts that are discussed in this week. Followed by we will be solving few assignments questions from the previous year, that is from August 2022, Introductory Organic Chemistry 2. We are not supposed to discuss the assignment sets of this year, so that is why we will be discussing previous year assignment questions so that it will be easy for you to solve the assignment set of this year. Okay, so coming to the first sessions, that is the summary of the week one. Here we have discussed two concepts, that is essentials of NMR spectroscopy and electrophilic aromatic substitution reaction. So in essentials of NMR spectroscopy, sir have discussed the chemical shift, shielding, frequency, etc. And as as is given in this figure, this x-axis represents a chemical shift, which is represented in delta, and the left hand side denotes small chemical shift, and the right hand side denotes small chemical shift, and the left hand side denotes larger chemical shifts. So coming talking about the fields, the right hand side will be high field or up field, and left hand side will be low field or down field, and frequency will be low towards the right hand side, and it will be high towards the left hand side. And talking about shielding, towards right hand side it will be highly shielded, and towards left hand side it will be deshielded. Highly shielded meaning there will be more electron cloud around the hydrogen atom or carbon atom, and deshielded means the electron density will be lower in that region. So these are the concepts that have been discussed in first lecture. Then, then the regions of proton NMR spectrum have been discussed, where we have given tetramethyl as the standard of the NMR spectroscopy, which is having a value of 0 ppm, and from 0 to 3 ppm we can see saturated CH3, CH2, CH that are not next to oxygen. Saturated CH3, CH2, CH, which are not adjacent to oxygen, will be seen in the region of 0 to 3 ppm. Okay, and in the region of 3 to 4.5 ppm, saturated CH3, CH2, CH that are adjacent to oxygen are seen. Like here, like R, O, R groups will be seen in this region. And in the region of 4.5 to 6.5 ppm, protons on unsaturated carbon, that is protons of alkenes, will be seen. And in the region of 6.5 to 8.5 ppm, protons on unsaturated carbons, that is aromatic hydrocarbons, will be found. And in the region of 8.5 to 10.5, protons on unsaturated carbons which are next to oxygen, that is aldehydes, acids, etc., will be found in this region. So these are the regions of proton NMR spectrum. How different protons will be distributed around the 1H NMR spectrum. Then regions of the 13C NMR spectrum, coming to that, in the region of delta 50 to 0. Delta means chemical shift. In the region of 50 to 0 ppm, saturated carbon atoms like CH3, CH2, CH, etc., will be seen. And in the region of delta 100 to 50 ppm, saturated carbon atoms which are next to oxygen, that is CH3O, CH2O, etc., will be found in this region. Like ethers, etc., will be found in this region. And in the region of 150 to 100 ppm, like both unsaturated carbon atoms like alkenes and aromatic carbons will be found in this region of delta 150 to 100 ppm. And in the region of 200 to 150 ppm, unsaturated carbon atoms which are next to oxygen, that is C double bond O, will be found in this region. Like ketones, aldehydes, etc., will be found in this region of delta 200 to 150 ppm. Was this all clear while you were watching the lectures? I am just giving a brief summary of what is discussed in the week 1 session. Okay. There were a total of 6 lectures. Out of that, the first 3 lectures were talking about essentials of NMR spectroscopy, and the next 3 lectures were talking about electrophilic aromatic substitution reaction. So, whatever we have discussed in these 2 slides are regarding essentials of NMR spectroscopy, and in the final lectures I have discussed the relation between electronegativity of various atoms that are attached to the carbon, where the hydrogen is present, and the chemical shift values. Now coming towards the next session, that is electrophilic aromatic substitution, which is discussed from 4th lecture to 6th lecture. Sir have discussed about Friedel-Crafts alkylation reaction and its mechanism, Friedel-Crafts acylation reaction and its mechanism, and Getamat-Koch reaction, which is similar to Friedel-Crafts acylation reaction, but it will be resulting in formylation of aromatic rings. So, for references to these lectures, you can follow Claydon Organic Chemistry, chapters 311 for Essentials of NMR Spectroscopy, and chapter 22 for Electrophilic Aromatic Substitution Reaction. Do you have any doubt regarding whatever summary we have discussed so far? Then can we move to the assignment session? We will be
Yes, ma'am.
okay, okay. We will be solving assignment sets from previous year, that is 2022 Introductory Organic Chemistry 2. So with the help of these assignments that we will be solving, you can solve the assignment questions that will be given for this year. We are not supposed to discuss the questions that are given for assignment 1, because the solutions are not yet released and it will be graded. So coming towards the first question of Introductory Organic Chemistry 2 August 2022 lectures. So aniline does not undergo Friedel-Crafts reaction using AlCl3 because first option A, aniline is deactivated due to the minus R effect of the NH2 group. Aniline reacts with AlCl3 to form a Lewis acid base adduct Option C, both A and B are correct. Option D, none of the above. So, do you have any idea regarding what will be the answer for this question?
Option B.
Option B. It is the correct answer. Aniline reacts with AlCl3 to form a Lewis acid base adduct. When we come to option A, aniline is deactivated due to the minus R effect of NH2 group. So when we see the NH2 group, it is electron donating kind of group as it is having lone pairs, and it will be involved in plus R effect rather than minus R effect. So this option we can eliminate it out. Then aniline reacts with AlCl3 to form a Lewis acid base adduct as we can see here. It is having lone pair of electrons. The lone pair of electrons can coordinate with AlCl3, which is a Lewis acid, and it will result in this Lewis acid base adduct. So it will not undergo further Friedel-Crafts reactions. So option B will be the correct answer. Is this clear? Okay. Now coming to the question number 2. Which of the following have correct arrow pushing sequence? Nitration reaction of benzene is given and they have asked for the correct arrow pushing sequence. They have given four examples A, B, C and D, out of which only one arrow pushing sequence is correct. So which one will be the correct answer? Yes,
D option.
option A is the correct answer. So for explanation of this arrow pushing sequence, we will see the mechanism of nitration reaction of benzene. So, nitration reaction is carried out in presence of HNO3 and sulfuric acid. So, HNO3, this oxygen lone pair will abstract the proton on sulfuric acid, leading to formation of HSO4 minus, and this species, which is formed after the elimination of HSO4 minus, will be containing this H2O plus, which is very labile group. So when the lone pair of oxygen falls here, this H2O molecule will be eliminated, leading to formation of nitronium ion. So this benzene ring will be electron rich. It can add on to this positively charged nitrogen atom of this nitronium ion and lead to pushing of electron density towards this oxygen. It will result in the formation of this intermediate. So now the aromaticity of the benzene ring is disturbed, and for regaining the aromaticity, this proton will be abstracted by any basic molecule like HSO4 minus, which is eliminated here. So it will lead to the nitration product. The mechanism will be clear, I think.
Yes, ma'am.
Okay. So, as we have discussed, the correct arrow pushing sequence will be the electron rich benzene ring will be going and attacking the positively charged nitrogen, and the double bond O will break, and electrons will be pu- pulled towards oxygen. So, the correct answer will be option A. Anyone having any doubt in this? Is it clear?
Clear.
Okay. So, now coming to question number 3. In practical organic chemistry, tetramethylsilane is mainly used for option A, making volatile derivatives of alcohols, option B, a spectroscopic standard, op- option C, a solvent for infrared spectra, and option D, an antinoke in gasolines. So tetramethylsilane is used in practical organic chemistry for which of these four purposes?
Spectroscopic
Ma'am,
standard.
option B.
Option B. Yeah. It is used as a spectroscopic standard as we have seen while discussing the summary of the week 1. We have seen that tetramethylsilane is used as a spectroscopic standard and its chemical shift value is assumed to be 0 ppm. This is the structure of tetramethylsilane TMS, and here the silane is having electropositive nature compared to the CH3. So the CH3 will be more shielded and hence it will be coming towards the right hand side of the spectrum. So the correct option is tetramethylsilane is used as a spectroscopic standard. This is clear, right?
Yes, ma'am.
Okay. Now, nuclei having either the number of protons or neutrons as odd have dash spin. Nuclei having either the number of protons or neutrons as odd have dash spin. Option A integral, option B half integral, option C 0, and option D positive.
Half integral.
Half integral is the correct answer. So we can see an hint of why it is half integral. So if the number of neutrons and the number of protons are both even, then the nucleus has no spin. If number of neutrons and number of protons are both even, then nucleus has no spin. If the number of neutrons plus the number of protons is odd, then the nucleus has a half integer spin, that is like half, 3 by 2, 5 by 2, etc. If the number of neutrons and the number of protons are both odd, the nucleus has an integer spin, that is 1, 2, 3, etc. So here they have asked whether the nuclei having either the number of protons or neutrons. Uh, like either protons can be having odd spin or neutrons can have, or the number of neutrons are odd. So the spin of that nuclei will be half integral spin. Is it clear? If both the number of neutrons and number of protons are odd, then their sum will be even and it will be resulting in an integer spin of the nucleus. Here they have, in the question they have asked either the number of protons or the number of neutrons as odd. So that is why the nuclei is having an half integral spin. Is it clear? Anyone have any doubt regarding this? Nikhil, you have any doubt? Okay, can we move on to question number 5? Okay. Coming to question number 5, where a compound is given. So we have to find the number of distinct signals in the proton NMR spectrum. The number of distinct signals in the proton NMR spectrum. This is the compound that is given, and the options are option A 3, option B 4, option C 5, and option D 6. What will be the correct answer?
5 signals.
5 signals. That is the correct answer. If we consider this molecule, there will be 2 protons here, a proton here. Here 3 protons will be there. Here 3 protons will be there. Here 1 proton. Here 1 proton. Here 1 proton. Here 1 protons. Then if we keep a if we consider a plane over here, this if we number the carbons, sorry, carbons of the benzene ring as 1, 2, 3, 4, 5, and 6. When we are considering this plane over here, the proton 2 and 6 will be identical. They will be in the same chemical environment, and protons 3 and 5 will be also similar. They will be in the same chemical environment, and these two CH3s, they will also be in the same chemical environment. So we can consider this two protons as one set: 1, 2, 3, 4, and this two CH3s will be giving a separate set. Okay, these two protons will be coming in one region. Then next will be this proton, this proton. So three distinct signals we have found. This will be the fourth one, and these two CH3s will be coming as a total six integer one signal. 6 integral, 1 signal. 6 protons will be coming in the same region. Is it clear? How 5 signals are coming, 5 distinct signals are coming. Is it clear? These two CH, these two protons which are adjacent to this bromide will be giving one signal. Then this 2 and 6 2 and 6 uh, 2 and 6 carbons, the protons over there will be identical and it will be giving one signal. Protons over 3 and 5 carbon will be identical and it will be giving one signal. Then this 2 CH3s, they are identical and it will be giving a distinct signal of integration 6. And then finally this proton over here, it will be giving one signal. So total there will be 5 distinct signals in the proton NMR spectrum. Is this question clear to everyone? Hello. Is question number 5 clear to everyone?
Yes, ma'am.
Okay. If you any one of you are having any doubt in between, you can feel free to stop me at any time. Okay. So coming to question number 6, the 13C NMR signals are in the following order of chemical shift. So they have labeled three carbons, this carbon as A, this carbon as B, and this carbon as C. So we have to find the order of chemical shift of these three different carbons. What will be the correct order of chemical shift? This is the molecule. They have labeled three carbons. This has carbon A, this has carbon B, and this has carbon C. So we have to find the order of the chemical shift, and they have given four options. Option A where A equal to B equal to C. Option B where B greater than A greater than C. Option C B greater than A equal to C, and option D A greater than B equal to C. So what is the correct answer to this question? What will be the order of chemical shift? So we have seen the region of chemical shifts in 13C NMR while we were discussing the summary of this week. So according to that, what will be the order? I can show you the regions of 13C NMR spectrum in scale of ppm. So there we have been given saturated carbon atoms like CH3, CH2, CH, etc. will be coming in delta region of 50 to 0 ppm. Saturated carbon atoms which are next to oxygen, that is CH3O, CH2O, etc. will be coming in the range of 100 to 50 ppm. And unsaturated carbon atoms like C double bond C or aromatic carbons, they will be coming in the region of 150 to 100 ppm. And unsaturated carbon atoms next to the oxygen C double bond O, they will be coming in the region of 200 to 150 ppm. So now coming back to our question, can anyone predict what will be the range of A?
100 to 150.
100 to 150. 100 to 150 region is coming for alkenes and aromatic regions. So A will be coming in the region of 50 to 100 ppm as it is adjacent to oxygen like CHO or CH3O or CH2O. So A will be coming in the region of 50 to 100 ppm. Then what will be the value of B? Range of B?
200
150.
to 200 to 150.
Yeah, 200 to 150 ppm. And what will be the range of C?
Same as A.
Hmm?
Oh, sorry. It is 50, 0 to 50.
0 to 50 ppm. C will be coming in the region of 0 to 50 ppm. Because there is no adjacent oxygen, it will be coming in the range of 0 to 50 ppm. So which will be the correct option? Option A, B, C, or
Second
A?
option. Second option.
Second option will be the correct option, because B is coming in the range of 200 to 150 ppm, A will be coming in the range of 50 to 100 ppm, and C will be coming in the range of 0 to 50 ppm. So the correct option will be B greater than A greater than C. Is this question clear?
Yes, ma'am. Clear.
Okay. Now coming to question number 7. Find the number of signals for the given molecule in proton and 13C NMR spectra respectively. So this is the molecule given. We have to find the number of signals in the proton spectra and the 13C NMR spectra. So the options given are 3 1H signal and 4 13C signal. Option B 3 1H signal and 5 13C signal. Option C 4 1H signal and 4 13C signal. Option D 4 1H signal and 5 13C signal. So we have to see how many distinct carbon atoms will be coming and how many distinct protons will be coming. According to that, we can predict the number of signals of proton and that of carbon.
Option A.
Option
Option A.
Option A. So we can see what are the different proton signals coming and what are the different 13C signals coming. So here CH3 will be there. All the three protons will be identical. Here CH2 will be there. Those two protons will be identical. So two proton signals have already been there. And here there will be one CH. This will be the third proton signal. And these two CH3s will be identical as they are in the same chemical environment. So this will be giving the fourth proton signal. CH3 will be first proton signal. The CH2 will be second proton signal. The CH will be the third proton signal. And these two CH3s, they will be identical and they will be giving the fourth proton signal. So there will be four proton signal. There will be four proton signal, and we can see how many 13C signals are coming. This will be giving one carbon signal. This will be giving second carbon signal. So here also carbon is there. This will be giving third carbon signal. This will be giving fourth carbon signal. And these two CH3s, they are identical and they will be giving fifth carbon signal. Is this clear? So there will be 4 protons and 5 13C signals. Any doubts?
Okay.
So there will be 4 proton signal and 5 13C signal. So which are the 4 proton signals? The CH3 will be 1, the CH2 will be 2, the CH will be 3, and these two CH3s, they are identical and it will be 4th proton signal. And which are the 5 different 13C signals? This CH3 will be 1, this CH2 will be 2, this C double bond O will be 3, this CH will be 4, and these two CH3s, they will be showing the same 13C signal. So it will be the fifth one. So there are 4 Punnett signal, and 5 13C signal. Is this clear for everyone? Hello? Any doubt?
Clear, ma'am.
Okay. So coming to question number 8, the 13C NMR spectrum of a compound A contains two signals. So the 13C NMR spectrum is containing two signals, and in the proton NMR spectrum there is a singlet. And in proton NMR spectrum it is giving only one signal. Which compound is consistent with this data? They have given two information. In the 13C NMR spectrum it is containing two signals, and in the proton NMR spectrum there is one singlet. So which compound is consistent with this data? So they have given option A as ethanol, option B as dichloromethane, option C as acetone, and option D as bromoethane. So we can see the structure of each of these molecules. Ethanol will be CH3, CH2, OH. Dichloromethane will be CH2, Cl2. Acetone will be double bond of CH3, CH3, and bromoethane will be CH3, CH2, Br. So, in case of ethanol, when we see the 13C spectrum of compound A contains two signals. Yeah, it is having one CH2 which is adjacent to oxygen, and one CH3 which is away from the oxygen. So this will be coming around 50 to 100 50 to 100 ppm region, and this will be coming in the range of 0 to 50 ppm region. So there will be two 13C signals, but proton spectrum also contains two distinct signals for this. This will be coming in the region of 0 to 3, and this will be coming in the region of 3 to 4.5. So this will not be the correct option. Ethanol we can rule out. Similar is the case with bromoethane. Bromoethane will also be having two signals for 13C and two signals for proton. And in the case of dichloromethane, it will be having only one carbon signal and one singlet for proton NMR spectrum. So here they have given two signals in the 13C NMR spectrum. It is not matching with this dichloromethane. So this option can also be ruled out. Now when we consider the case of acetone, these two CH3s are identical. So they will be coming as a singlet. There are no other protons. So in the proton spectrum, there will be only one signal, and these carbon 13, there will be these two carbons will be coming in the same region, and the next will be this C double bond O, which will be coming in the range of 150 to 200 ppm. So this data which they have given, that is the 13C NMR spectrum of compound A contains two signals, and the proton NMR spectrum there will be a singlet, is matching with this acetone. So the correct option will be option C, acetone. Is this clear?
Ma'am? Yes, ma'am.
Okay. Now let's move on to question number 9. So, how many signals in proton NMR spectra will be obtained from the following compounds respectively? So, this is compound A, this is compound B, this is compound C, and this is compound D. So we have to see for each of the compounds how many signals will be coming in the proton NMR spectra. So for option A, what will be the number of signals in the proton NMR spectra? For option B, what will be the number of protons in the NMR spectra? For option C, what will be the number of protons in the NMR spectra? For option D, what will be the number of protons in the NMR spectra? So likely you have to find for these four cases. So they have given some options. You can find the answers and match with these options. So option A will be A is 2, B is having 1, C is having 3, and D is having 2 proton signals. And option B is A is having 2, B is having 1, C is having 4, and D is having 2 proton signals. Option C, where A is having 2, B is having 4, C is having 4, and D is having 2 proton signals. And finally, option D, A is having 1, B is having 1, C is having 3, and D is having 2 proton signals. So, what is the correct answer for this question?
Option B.
Option B. Let us see. So, in case of A, these three CH3s will be showing one signal, and the CH3 will be showing the second signal. So it will be showing two proton NMR signals. And option B, all the four CH3s will be coming in the same region. So it will be showing one signal in the proton NMR spectrum. And in option C, this CH3 will be showing separately than this one. And when we consider a plane over here, these two protons will be identical and these two protons will be identical. So 1, 2, 3, and 4. Option C contains 4 distinct proton NMR spectra, and option D, if we are considering a plane over here, these two protons will be in the same chemical environment, so they will be showing as a single signal, and these two protons will be in the same chemical environment, they will be showing as a different signal, so there will be two signals. So the correct option will be option B, where A is having two proton NMR signals and B is having one signal in the proton NMR spectra, C is having four, like 1, 2, 3, and 4. These are identical. 2 will be identical with this, 3 will be identical with this. So there will be 4 distinct signals in the proton NMR spectra, and D will be having 2 different signals in the proton NMR spectra. Is this clear? Okay. So the correct answer will be option B, where A is having 2, B is having 1, C is having 4, and D is having 2 distinct signals in the proton NMR spectrum. Now coming towards the question number 10. Predict the major product of the following reaction. They have given nitrobenzene and one alkyl chloride in the presence of AlCl3. What will be the major product that will be obtained in this reaction? Option A is ortho product, option B is meta product, option C is para product, and option D no reaction. What will be the correct answer? Any guesses?
Option B.
Option B. So now let us see the mechanism of this Friedel-Crafts alkylation reaction. So before going into that, we should see At what position nitration is possible? So we can see this is the structure of nitrobenzene. So since nitro is an electron withdrawing group, this electrons of this double bond will be uh, withdrawn towards the nitro group. It will be going in this direction, and this oxygen will be getting O negative, as we can see here. Since this double bond is broken, it will get a positive charge at this region. Now, since here there is a positive charge, this double bond will delocalize into this position, giving a positive charge at this center. So this is the third resonance structure. So here there is a positive charge. This double bond will delocalize into this position, giving a positive charge at this center. So this is the fourth resonance structure. And now this O minus will push the electron density in this direction, and this C double bond N will break, and it will lead to regaining of the aromaticity. So this is the resonance structure of aromatic nitrobenzene. So we can see at the ortho position and at the para position there is positive charge. So this is electrophilic aromatic substitution, and since the ring is having positive charge over it, so this reaction, that is the alkylation of the nitrobenzene, is not feasible. So the correct option will be there will be no reaction. So we can see the mechanism again. This is the structure of nitrobenzene. So nitrobenzene, this nitro group is electron withdrawing group. Here minus R effect will be predominant. So this nitro group, this double bond will migrate in this direction, and this O minus will be forming. So here there will be a double bond over this nitrogen, and the O minus will be forming. And since the double bond is migrating from here, there will be a positive charge generated at the center. Now since there is a positive charge at the center, this double bond can delocalize over here, and it will result in formation of a positive charge over here. Then since there is a positive charge over here, this double bond will migrate in this direction, and it will give a positive charge over here. Now for stabilizing this positive charge, the C double bond N bond will be migrating in this fashion or delocalizing in this fashion, uh, which is driven by the pushing of electron density of this oxygen lone pairs. So these are the different resonance structures of nitrobenzene, and in the ring, as we can see, there will be an overall positive charge. In the ring, there will be an overall positive charge. So for alkylation reaction to take place, the ring should be electron rich. Here the ring is electron deficient, and it is having an overall positive charge over the ring. So in this case, the Friedel-Crafts alkylation reaction will not take place. So the correct option will be option D, no reaction. Is this clear?
Ma'am, so for meta-directing group, Friedel cross alkylation is not possible, isn't it?
Yeah.
Acylation, ma'am.
What?
Friedel cross acylation.
Acylation will also be not possible in this case,
Okay, okay.
because the ring is having overall a positive charge over it. So it cannot go and attack over the electrophilic groups. That is why the reaction is not feasible over here. Is it clear?
But in the metabolism, there oxygen, the electron density is greater than ortho and para.
Yeah, but since the ring is overall having a positive charge over it, it is not that electron rich in nature, so that the alkylation reaction or acylation reaction can take place. Okay.
Okay, ma'am.
Ring is having an overall positive charge over it because of the electron withdrawing effect of the nitro group. That is why ortho para positions are completely like we can rule out because it is having a positive charge directly at that position. And since the ring overall resonance structure is having a positive charge over it, because of that meta alkylation also not possible. So there will be no Friedel-Crafts alkylation reaction taking place in this case. Is it clear?
Yes, ma'am, it is clear.
Hmm. So coming towards the question number 11, predict the major product in the following reaction. So here an intramolecular Friedel-Crafts alkylation reaction will be taking place. So what will be the major product that is formed in this reaction? So four different options are given. What will be the correct option?
Option A.
Option A. Option A is also a possible answer, but the correct answer will be option C. So we can see the mechanism of that reaction. Okay. These two products are possible, but the major product will be option C. So we can see the mechanism. So Cl will lone pairs of Cl will coordinate with AlCl3, resulting in the formation of this complex. Then this can get like this will be eliminating like minus Al as AlCl4 minus, generating a carbocation at this position. So if the aromatic ring is going and attacking directly at this stage, this is a secondary carbocation. If the if the electron rich aromatic ring is directly going and attacking at this stage, it will result in formation of the product A that you have told. But this is secondary carbocation, and here it is having a possibility to generate a tertiary carbocation. So this proton will migrate to here and it will result in the formation of a tertiary carbocation here. This is a tertiary carbocation. So compared to secondary carbocation, tertiary carbocation will be more stable. So the formation of tertiary carbocation will be more favored. Now the double bond will go and attack over this carbocation. It will result in the formation of this intermediate, and Cl minus which will be present in the system, it can abstract this hydrogen and lead to regeneration of the aromaticity. So the major product will be option C. Option A will also be forming, but it will be to a lesser extent. Option A, sorry, where a six-membered ring will be generating, it will be also forming. 1, 2, 3, and 4. It will be also forming, but here the secondary carbocation is less stable. So it will generate the tertiary carbocation as formation of the tertiary carbocation is feasible in this structure. So the major product will be option C. Is it clear?
Yes, ma'am, it is clear.
Okay. So if the question is like you can write what are the possible structures that are formed in this reaction, you can write both A and option C. But here they have asked for the major production in the following conversion. So the correct option will be option C. Anyone having any doubt regarding this question? Is this question clear for everyone?
Clear.
Okay. Now coming to question number 12. Predict the major product in the following reaction. So this is benzene substituted with OMe plus HCN plus HCl in the presence of AlCl3. This is the conditions for Gattermann-Koch reaction. So what will be the major product that is formed in this reaction? Ortho substitution, meta substitution, both ortho meta substitution, para substitution. What will be the major product that is formed in this reaction? So you will be familiar with the mechanism of Gattermann-Koch, right? Any guesses? What will be the major product? Option B. You mean this one, meta one. I will just label A, B, C, D. So most many of you are telling ortho substitution product will be the major one. Let us see the mechanism. So here this OMe will be electron donating in nature. So this lone pair of electrons will be pushed in this direction and it can directly go and attack this HCN here. But since resonance will be more when we are going to the para position, that will be more favored. It can undergo both ortho substitution as well as para substitution, but delocalization or resonance will be more in case of para substitution. Here it will be more delocalized, right? When it is coming from this electrons, when it is traveling from this lone pair of oxygen towards this para position, it will be more delocalized. So para substitution will be the major one. So this lone pair of electrons will be pushing in this fashion. Then this double bond will migrate in this side and this will go and attack the carbon of HCN and this will abstract the proton from HCl. So this will result in the formation of an imine here. Now this want to regain the aromaticity. The aromaticity of the system is lost. So for that Cl minus of this HCl will abstract this proton over here. Then the negative charge that will be generated will migrate in this fashion, giving back OMe. This positive charge on oxygen is also not favored. So we will get this product, so which upon hydrolysis will result in the formation of this aldehyde at para position. Is the mechanism clear? Ortho substitution is also possible. Both ortho and para aldehyde will result, but the major product will be the para one because it is undergoing more delocalization of electrons. That is why the para product will be the major one. I hope the mechanism is clear to everyone. Is it clear?
Yes, ma'am.
Okay. So the correct option will be option D. Now coming towards the last question in this session. For the following reaction scheme, identify the reagents. So here a Friedel-Crafts acylation reaction is taking place followed by a Clemmensen reduction for removal of this ketone resulting in the formation of this alkane. So what will be the reagents that are used over A and B? Option C. Yeah, option C is the correct answer. We can see the mechanism. So here this is the acid chloride that will be used. That is 1, 2, 3. Propane acid chloride. Then this lone pair of oxygen will migrate in this fashion and AlCl4 will be removed, resulting in the formation of this intermediate. So the benzene ring will go and attack on this carbon of this intermediate acylium ion, and this positive charge on oxygen will be neutralized. It will result in the formation of this intermediate. So here the aromaticity of the benzene ring is lost. So for regaining the aromaticity, this proton will be abstracted and the negative charge formed will migrate over here, and it will result in the formation of this acylated benzene. Now we have to remove the ketone. So here we will be using the Clemmensen reduction condition, that is zinc amalgam and HCl. So it will result in the formation of this alkane by removal of this ketone. So the mechanism of Clemmensen reduction is as shown here. It will be following a carbenoid intermediate kind of mechanism, finally giving alkane in place of this ketone. Is the mechanism of this Friedel-Crafts acylation clear to everyone?
Yes, ma'am.
Okay. So the correct option is option C, that is CH3CH2 COCl AlCl3. That is the Friedel-Crafts acylation condition and then Clemmensen reduction. So these are the questions that were discussed in assignment 1 of last year. So I think this will be helping you to solve assignment 1 of this year. Do you have any doubt?
Ma'am,
Yeah,
this year even CV mechanism is given.
even CB mechanism.
Yes, ma'am. It is given in the assignment.
Okay, okay.
Which reference
I
book?
have gone through the assignment questions. Actually, you can follow the lectures of week 2 for solving week 1 assignment questions. You can go through the
Okay.
week 2 lectures so that you will be able to solve the week 1 assignment questions. I think some problem was there while um, distributing the questions.
Okay, ma'am. Any reference book for that?